Hello everyone. Before we begin our presentation, I would like to introduce our group member. This project was completed by the 4 group members, including me. And my name is IBRAHIM, and number BINTI is FFT2073. And the second member is Sophie.
My name is NORSOFINA. My basic number is E25A360.
The member is JAUHARAH.
My name is JAUHARAH with Dataset. My basic number is E25A3547.
And the last one is Sheila.
My name is NORAQILAH. My basic number is E25A3742.
In this video, we will be presenting our statistical project on the relationship between diet, type, and disease resistant among patients. Disease resistant. The study uses Dataset A. It consists of 200 observations collected from patients. Each observation represents one patient, and each patient is classified based on 2 variables. The first variable is diet type. There are 3 diet types included in this study, which are diet type A, B, and C. The second variable disease categorized by resistant and non-resistance. The purpose of collecting this data set is to investigate whether different diets may influence or be associated with patients resistant to disease. Before performing a statistical test, the data is first summarized using a joint frequency distribution table. This allows us to clearly observe how patients are distributed diseases across different diets and disease resistant categories. In total, there are 146 patients who are classified as resistant and 54 patients who are classified as non-resistant, making a total of 200 patients. In the study, this overview provides the foundation for the statistical analysis that we will explain in the following session.
The objective of the study the first objective is to summarize the relationship between the type and disease using a joint distribution method, which is help us organize the data and improve it. The second objective is to determine whether there is a statistically significant relationship between the data and disease resistant and high presence in disease. Also, one point is this question. Based on this objective, there is this question of is there a significant relationship between the data and disease resistant among patients? To answer this question, two hypotheses are proposed. One hypothesis states that diet type and disease resistant are independent. This means that the type of diet gene model does not affect their disease resistance. The alternate hypothesis diet type and disease resistant are not independent. This means that there is a relationship between the diet type and disease resistance. These hypotheses allow us to apply the statistical test to determine whether the observed data are right enough and then to support the existence of the relationship. To test this hypothesis, the test of independence is used. This test is suitable for the study because the both variables involved, diet type and disease resistance, are categorical variables. In addition, the data is presented in the the form of frequency count. The high-spread test helps in determining whether there is a significant association between two categorical variables by comparing observed frequency with expected frequency. Formula for the high-spread test of the method is the sum of the sum of the square difference between observed frequency and expected frequency divided by expected frequency. Before applying the test, several assumptions must be satisfied. The first assumption is that the observations are independent, meaning that each patient contributes only one observation to the data set. The second assumption is that the data is presented in the form of frequencies rather than percentages or raw measurements. And lastly, the expected frequency for each cell in the contingency table must be at least 5. In this study, all expected frequencies meet this requirement. So the high-spread test of independence is appropriate to be used. Next, we constructed the observed frequency table from the data. For diet type A, there were 49 resistant and non-resistant. The UV had 49 resistant and 17 non-resistant measures. Diet type C had 48 resistant and 17 non-resistant measures. Then we calculate the expected frequency using the test formula. To find the expected frequency, multiply row total in column total then divided by sample size total. For example, for data A, there is resistance 69. 146 divided by 200. Then we will get this data. After that, we need to find the S square. To find this first, 49 minus 50.7 square and divided 50.357. Repeat this step with every data and find the sum. The total transfer value of them was 0.213. The degree of freedom for this test was 2. At the 5% significance level, the test critical value is 5.99. See the calculated test value of 0.213 is less than 5.99. We fail to reject the joint hypothesis. Using Excel, the p-value was approximately 0.90. Seeing the p-value is greater than 0.05, we again fail to reject the null hypothesis. This means there is no significant relation between data and resistance at 5% significant level. That's all from me.